So today's notes are on the Pythagorean Theorem, and I'm only going to do one video. It might be a little bit long, but we'll get through it. I'm not sure if you have learned the Pythagorean Theorem before or not. Sometimes they teach it in 7th grade, pre-algebra, to get you ready for the PSSA, so you might know some of this already. But the first thing that you have to remember is that the Pythagorean Theorem is only for right triangles. So you have to have a right angle. If there's no right angle, then you cannot use the Pythagorean Theorem. But we're always going to label our sides like this. The one that's across from the right angle, the longest side of that triangle, is always going to be C, and we call that the hypotenuse. So the hypotenuse is always C, it's always the side across from the 90-degree angle. The other two sides, A and B, those are called the legs. And it doesn't matter which one is A and which one is B. It's not like A has to be the smaller side and B is the bigger side. That doesn't matter. You can put B up here and A down here. It doesn't matter. The only thing that matters is that C is the longest side. And then the Pythagorean Theorem is A squared plus B squared equals C squared. So we're always going to be using that theorem over and over again to solve all of these problems. So the first slide here just asks, are these a right triangle or not? So if I were to make a triangle, if I were to give you 3 popsicle sticks or 3 drinking straws that measured 15 centimeters, 17 centimeters, and 8 centimeters, and you formed a triangle, would that be a right triangle? So the way we're going to do this is, first you have to look and see where's the biggest side. So the biggest side is 17, so that's going to be our C. So now I'm just going to plug these numbers into the Pythagorean Theorem. A squared plus B squared equals C squared. So 17 has to be C, and it doesn't matter which one you make A and which one you make B. So I'll just make 15 squared A and 8 squared B. So I made 15A and 8B. You could have switched them if you wanted, but C, that's the important one. Okay, so now I'm just going to plug this into the calculator. So if I plug in 15 squared plus 8 squared, I get 289. And if I plug in 17 squared, I also get 289. Since they're the same number, they're equal, yes, this will be a right triangle. There will be a 90-degree angle. So for the next one, so my C has to be the biggest one, 25, and then I can make the other two A or B. So I'll have 10 squared plus 24 squared equals 25 squared. And again, I'm going to plug the left side into the calculator, and I get 676. And I plug in 25 squared into the calculator, and I get 625. They're not the same, so no, this is not a right triangle. Okay, so no, it's not. Now, the last one's a little bit tricky, and I know we've been trying to get better with units, so we can see we have yards, feet, and inches. So we have to get them to be all the same first before we can plug into the Pythagorean Theorem. So I'm going to turn everything into inches. So 3 yards times 3 gives me 9 feet, and then 9 feet times 12 gives me 108 inches. And then 12 feet times 12 gives me 144 inches. So my 3 sides are really 108 inches, 144 inches, and 180 inches. So now the biggest side is 180. So I'll have 108 squared plus 144 squared equals 180 squared. And on the left side here, I get 32,400. And on the right side, I get the same thing. So yes, this would also make a right triangle. Okay, so if they ask if it's a right triangle or not, we just plug it into the Pythagorean Theorem. If the numbers are equal, then yes, it's a right triangle. If the numbers are not equal, then no, it's not a right triangle. And there's a graded worksheet on just this concept where you're determining if it's a right triangle or not. Now, the main way that you're going to use the Pythagorean theorem is to find the missing side of a triangle. So if I'm going to find the missing side of this triangle, okay, you look, here's my right angle, so the side across from that, that's C. Okay, and then I can make these two A and B. It doesn't matter which one I make which. So I have 14 squared plus 48 squared equals C squared. Now I have to solve for C. That's what I have to do. So the first thing is I'm just going to plug this right into the calculator. And when I do that, I get 2,500 equals C squared. Now, to get rid of this square, we have to take the square root of both sides. So when I take the square root of 2,500, I end up getting a nice even number for C. So C is 50 yards. Okay, so this exponent up here is an exponent. It's not a 2, so we're not going to divide by 2 to get rid of it. You have to take the square root to get rid of it. Sometimes you'll get a decimal, and we'll just round to one decimal place, but in this case we got a nice even number. Now, that was if we're solving for C. If we have to solve for A or B, it's a little bit different. So here's my right angle. Here is C. So now I can make this A and this side B, or I could have made this B and this A. It doesn't matter. Okay, but now when I set up my Pythagorean theorem, I have 4 squared plus B squared equals 8.5 squared. So now I have to solve for B. So this solving is just a little bit different. The first thing you want to do is we want to square our numbers. So 4 squared is 16. And 8.5 squared is 72.25. Okay, and that's just by plugging it right into your calculator. And if you're having trouble finding the square button, just call me over and I'll show you where it is. Okay, so now I have to get B by itself. So I'm going to subtract 16 from both sides. So I get that B squared is 56.25, and don't round that number, leave everything exact. Okay, and now I see this B again. So with a square, so to get rid of that, I'm going to take the square root of both sides. So I get that B, and this is another exact, it's exactly 7.5, and my units are centimeters. So the only difference between the last one and this one is there's this extra step here of having to subtract from both sides. That's it. That's your one extra step. If you're solving for A or B, is to subtract that to get rid of it. Now, the next slide, it's actually a little bit simpler than the previous one because it tells you what A, B, and C are. You don't have to determine which one's A or B or whatever. So this one, A, B, C, would be set up as 9 squared plus B squared is 15 squared. So that gives me 81. Plus B squared equals 225. I'll subtract 81 from both sides. And B squared is 144. And then again, to get rid of that square, I'm going to take the square root of both sides. So B is 12. And there's no units on this, so I don't have to include any units on that. And then this one over here to the right. Now we're solving for C. So I'll have 7.1 squared plus 6.6 squared equals C squared. I can plug that whole left side into my calculator to get 93.97. And now again, I'm going to take the square root of both sides. And this is the first time that I get a decimal, 9.6938 and so forth. So I'm going to round it to one decimal place. So that 9 will change that 6 to a 7. And again, there's no units, so that's my answer. Alright, we have one more type of problem, and this is where they just kind of describe what's happening. Now, I think it's easier to always draw a triangle if you want to. So it says the lengths of the legs of a right triangle are 16.5 and 22.9 inches. What's the length of the hypotenuse? So here's my triangle. They want to know the length of the hypotenuse, so that's C. And then the legs, it doesn't matter which one's 16.5 and which one's 22.9. But those are going to be my A and B values because those are the legs. So 16.5 squared plus 22.9 squared equals C squared. So when I plug this left side into the calculator, I get 796.66. And again, I didn't round anything yet. Now I'll take the square root of both sides, and I get that C is 28.225, and so on. So I will round that to just 28.2. Oh, and my units are inches. So again, we're just rounding to one decimal place. That 2 will not make that 2 move up, so it stays as a 2. And now the bottom one here. It tells me the length of the hypotenuse, so that's the one across from the right angle, is 624. One leg measures 233. It doesn't matter which leg you make 233. What's the length of the other leg? So I'll just make this A, and we'll make this one B, and we know that one's C. So I'll have A squared plus 233 squared equals 624 squared. And these numbers are going to be kind of big, but when I plug this into the calculator, we get 54,289. And then on the right side is 389,376. And so now I have to get A squared by itself. So I'm going to subtract this 54,000 from both sides. So I get that A squared is now I'm going to take the square root of both sides here to get rid of the square. So I get that A is 578 and then the decimal. So I will round it to one decimal place. Look at the 8, that 6 will turn that 8 into a 9, and my units are millimeters. So there were really 4 different type of problems here, determining if a triangle is a right triangle or not. So that's when you're just plugging in and determining yes, they're equal or no, they're not. Then they describe it like this, where they give you the hypotenuse or the leg. They give you the actual triangle, or they just give you A, B, and C and tell you what to solve for. So at the bottom here of the slides, you can see the last 2 slides are extra practice. So you can just try each one of those 4 problems. There are 2 worksheets in the crate for you if you want some extra practice, and then there's also the graded worksheet that you need to turn in for 19 points. So if you have any questions on this, or if you need any help, just please ask, and I can clarify anything.